Modulation is digital communication, binary data bits, over analog waveforms. It is the process of varying one or more properties of a high-frequency periodic waveform called the carrier signal with a modulating signal which typically contains information to be transmitted. Amplitude, frequency, and phase are the three basic elements of a waveform that can be varied. Wireless and radio cards use different types of modulation methods to represent data bits as they are delivered via an RF signal based upon the technology in use. A baseband signal is an original transmission signal that has not been modulated or has been demodulated to its original frequency. Amplitude modulation, AM, like AM radios, varies the power of the signal. Frequency modulation, FM, like FM radios, varies the frequency of the signal. Both AM and FM allow only one bit to be derived for each state change or lack of state change. This process is referred to as binary phase shift keying, BPSK. Phase modulation is based upon phase shifts of an RF signal and open the door for quadrature phase shift keying, QPSK. Phase modulation allowed 2 bits to be derived from each signal state change, depending on where in waveform the state changes. 802.11n and 802.11ac use quadrature amplitude modulation, which is a hybrid of phase and amplitude modulation. The orthogonal frequency division multiplexing, or OFDM, employed by these PHYs use BPSK and QPSK phase modulation for the lower data rates, while the higher data rates use 16 quadrature amplitude modulation and 64 quadrature amplitude modulation, providing 16 bits and 64 bits respectively. Further, 802.11ax, the new standard we call Wi-Fi 6, leverages orthogonal frequency division multiplexing access, OFDMA, which is a multi-user version of OFDM, allowing up to 1024 quadrature amplitude modulation, or QAM.